So with this, we can start. Let me give a brief introduction. So I'm very happy to have today with us Dr. Achim Struve from Outlier Ventures, who is one of the most prominent token engineers in the space, working on different types of models demonstrating token economic structures, the token economic effects, parameter selection processes, and to some extent also prediction of events or trajectories of the system, in the sense that token engineering is a discipline that is aiming to design and define outcomes of different mechanism designs. And this is what we will talk about today. Today, the topic will be adoption adjusted vesting, which is, Achim will tell us in more detail, but which is a way to model how adoption of an ecosystem has an impact on the vesting structure of the token distributed throughout the economy. So without further ado, I want to hand over to Achim. He told me that he's going to have a 30-minute presentation, and then we can have a discussion. So feel free to always ask questions in the chat. We will collect them over time, and then by the end we will have a moderated discussions with Achim, and he will present and give feedback and is happy to entertain all the questions. So Achim, please.
Yeah, thank you so much, Chris, for having me today. It's really a pleasure and honor for me to guide you all through this seminar now about adoption-adjusted vesting. Yeah, my name is Achim, and I am married. I have 2 children, and I'm the token engineer at Outlier Ventures. We, as Outlier Ventures, we are the leading #1 accelerators for young Web3 startups. And yeah, we have a very big investor network and more than 250 portfolio companies. And based on this, like, everyday work I have, like, with these young startups, I derived like some new approaches for vesting, which I would like to share with you today. So, but first, let's have like a little bit higher level overview of what the problem actually is that we are facing. So the overall problem all of us as token engineers facing day by day is that token ecosystems are of very complex and dynamic nature, all the different stakeholders interacting with each other. And it really creates a very non-linear behaviors, and it's difficult to parameterize all this whole ecosystem parameters and to find like suitable values, initial values, and also in-market values on how to essentially define, for example, rewards and so on, or other metrics. And this is really a difficult thing that we are facing, because it's everything interdependent, as I said. And we have like different sections for an ecosystem that we are dealing with as token engineers. So we have at the beginning the fundraising and the corresponding token allocations and vesting. So essentially how the token supply gets emitted into the ecosystem. Then we have to think about the market making for the token, about liquidity. We also want to include like certain user adoption scenarios for the product, but also for the token, if it's not the same, it or not tied together. In many cases, it is tied together. And then we want to look also at the business sustainability, because at the end, every or most token ecosystems we are working with, there is essentially also a business behind it. And we have other aspects like token sinks, sources, utilities, policies, and mechanisms. All of these things need to be parameterized, and all these different fields are playing together and are interconnected, and it's really difficult to like have an intuitive idea of an ecosystem, how it will develop in the future. So this is like the overall problem, and many start by just looking at one of these aspects. So for example, just fundraising. But fundraising and the corresponding token allocations, investing, have a huge impact on the sustainability and the whole ecosystem long-term or medium-term. And that's why we really need to approach those ecosystems in a holistic and holistic way, from a higher level perspective and a macro perspective. So what is the solution for this problem in general? Less subjective human decision-making on ecosystem parameters is one direction. Less slow and inefficient governance processes, less social attack vectors, and more algorithmic control in the ecosystem. So I remember the talk of Trent McConaughey at ETHCC this year when he said like the best governance structure is no governance. And I believe he is right there, because all these like human interactions before the creation of the ecosystem, but also like during or while running the ecosystem, are potential weak spots or make room for attack vectors. And that's why I thought about introducing ecosystem controllers such as this one. So this is like a high level overview of how the controller works in general. There is like the controller that receives an error from the input. So if you consider like you have a certain value that should be approached and it is not approached because you have like the reality looks different from what your target value is, then this produces an error, and this will be fed into the controller, which then creates an actuating signal, which goes into the plant in terms of a token ecosystem. This would be like our token economy. And this economy then produces certain KPIs or metrics, like the outputs of this decision or this actuating signal, which can then be fed back into this error controlling or error controller in the end. So this is like the fundamental closed loop controller design that we see everywhere in traditional engineering applications. And we can use and leverage this also for token economies in general to mitigate like the human risk. So please don't be afraid. This is the only slide that has like these mathematical equations. So just hold on or close your eyes if you don't like math, no problem. But I just want to bring this up because this is essentially like the most common or most known, one of the most known controller designs. It's the so-called proportional integral derivative PID controller. And it consists essentially like out of a constant gain factor multiplying the error. Then you have like an integral that accounts for the past errors and scales this into the equation. And we have also the derivative, so the speed of the error if you want. And all these different terms will be added together after they will be scaled up or down with a certain coefficient, and they then create like an input signal or an actuating signal for the plant. So in here on the left-hand side, you essentially see what happens if these different coefficients are getting changed, and how essentially a signal approaches the target signal when changing these coefficients. And it's just for you that you have like seen one time like how a controller normally looks like. Obviously you can like define these controller equations as you like. So there are many different ways how you can essentially define and engineer a controller. This is just an example for you that you've seen it one time. Okay, and now let's come to the token ecosystems. So for token ecosystems, what type of metrics are we facing, or KPIs normally in ecosystems? So we have, for example, like TVL, total value locked. We have user acquisition or user number, user growth, transaction counts, token volume, token price, revenue, expenditures, business profitability, social media traction, circulating supply, liquidity depth, and developer commits, for example. So we can also track like the activity of developers if we want. Obviously, there are many more metrics and KPIs we can track for token economies. And maybe you noted already that not all of them are on-chain. So we might also include off-chain metrics in our conclusions or for our controller design if we want. Okay. And now the question is, what type of controller variables can we leverage to influence these metrics and these KPIs? And again, there is a whole big list of certain variables we can use here. For example, we can change a rewarding rate when you have like rewards for staking, for example, or you can also change the incentivization rate, vesting rate, liquidity changes, minting, burning rates, buybacks of the business, or sales, or liquidations, expenditures, and so on. So there is really like a big set of control variables you can think of. And you can, by changing these variables, you will directly influence the ecosystem metrics and KPIs. And obviously these KPIs can then be used as a signal being fed back to the ecosystem controller set or set of controllers that then again change or maneuver these different control variables. Okay, I think this should be clear. And now we are already approaching the first little exercise. I would encourage you to participate. So it's a very quick one. Oh, I already see there are maybe some questions in the chat. Let me see.
Yeah, yes, we had some questions in the chat, Achim, but I mean, we're just collecting them so that we don't forget them. But
Okay.
you don't need to respond now. So I think all is good, and you can continue. We're just trying to like have a conversation in the chat, like answer some
Okay.
community feedback.
Okay.
But yeah.
Then please do it right now. I have a little exercise here. So when you look at this list of control variables and these ecosystem metrics and KPIs, what pairs of control variables and ecosystem metrics could you think of? So what would make sense to choose as a control variable for which metric or KPI? And note, you can also pair not just a one-to-one relationship, but you can also pair like a multiple to multiple relationship if you want. So using like several control variables together to steal like one metric and vice versa. Oh, not vice versa, but yeah, in general, what would you think of? So what type of pairs can you think of when you look at these set of control variables and ecosystem metrics? You can also add like some other ones, and I would like to invite you writing some ideas and of typical pairs here in the chat right now. Don't be shy. You can also, okay, Ben is lost. Okay, a few suggestions here, great. Some more. So really don't get confused by the equation I showed you before, like regarding the PID controller. If math is not your thing, you can also like just follow up and forget about this for this session if it's too confusing. Yeah, okay, we already see some examples. Thank you very much. Okay, great. Then let's move on. because, yeah, so in this session today, we want specifically talk about the vesting rate as a control variable to token price. Because like in practice and in working with models basically on a daily basis, I saw that this is like one of the main influence factors for also sustainability for token ecosystems. And that is why, and we basically see this also in our everyday practice, looking at certain token valuation developments over time, especially when they have like very aggressive vesting at the beginning. So the challenge with vesting or correct vesting terms is that there is no appropriate vesting essentially, because no one really knows what are appropriate vesting durations for a sustainable token ecosystem. What are the best vesting intervals? I mean, in this, for intervals, we can easily say like shorter periods of vesting are better. So if you vest like once a month or once a quarter, this will always like trigger very transient events in the ecosystem. And it's better to vest like on a daily basis. For example, it's a little bit more smooth. So this, I think we can have an answer here. However, there are also other questions regarding like what shape of vesting should the vesting have? Like, is it linear vesting or exponential or like a logarithmic vesting? What about cliffs? Should we apply like cliffs into our vesting schedules, or should we maybe go for a very different approach by using like milestone vesting, which means essentially when a certain milestone is reached in the ecosystem, only then like a bulk of supply gets released into the market? Or we can also apply like early claiming penalties and so on. So there are so many questions around vesting and how to design good vesting schedules essentially.
Achim, can I intercept really quickly, because
Sure.
I want to make sure that everyone is on the same page. So could you please take a minute to define vesting for us? So like which tokens are you distributing to whom? What are the conditions? What is the vesting problem, and how do you frame it in this context?
Okay, sure. So with vesting, we in general we mean essentially the release of token supply into the market, and specifically or most applicable for like early investors or early contributors for an ecosystem. They will get like a certain token allocation, and this allocation will be released into the ecosystem most commonly by a vesting schedule. So it won't be released like on day one when the token launches, but there will be a schedule on which this token gets released. And now the question is essentially how to design such a schedule or how to approach this, because as I said, there is no appropriate vesting, there is no good vesting schedule, because no one can essentially forecast the future and the actual demand for the token. Okay.
Nice, thank you. Yeah, nice.
Great. Thanks for the question. Okay, and now we go a little bit deeper and look at an example from the QTM, which is the quantitative token model. It's like one model that I developed where we can essentially forecast token ecosystems from a macro perspective. And we assume a certain, for this example, we assume a certain adoption scenario. And this adoption scenario manifests through like a product revenue per month growth curve, like here on the bottom left-hand side. So essentially just a curve that prescribes how much revenue will be generated per month for this protocol or in this protocol. And then there's also an adoption curve for the token. So essentially an effective buy pressure for the token in dollar denomination. And this adoption scenarios, or this example, it's really like arbitrary. You can also choose other ones. It's just like for exemplary purposes. So just like know that this is an example on how like demand can come into the ecosystem. And in general, there are like different phases for the ecosystem. So at the beginning, there is most often the building phase where we have quite low revenue and low buy pressure and demand for the token in general. And then later on, when everything goes well, then we have the scaling phase where the revenue goes up and also the buy pressure goes up. And eventually we will reach a saturation maturity phase where essentially the slope of the growth decreases again. And this can be said like also for the token demand. And now the challenge is that when we look at traditional vesting schedules, so now this is a vesting schedule here where you see like the amount of tokens for different stakeholder groups in an ecosystem. And you see like traditionally, these tokens will be emitted quite fast. So like in the first 2 or 3 years, this was essentially like the standard recently. And we see that there is really like a supply flood hitting the market while there is low demand and low revenue for the token. So we are still in the building phase, but the tokens get flooded into the market. So there is a lot of supply, but not much demand. And this will end up obviously in a price drop. So the blue line here is essentially the drop in price for the token. Obviously, this model is not able to simulate anything accurately, but we can at least see like how different higher level numbers and assumptions can play out under certain assumptions. So it's interesting because it's essentially showing us what we already saw and see in the market. So it's in that sense, it is quite accurate that we can model this behavior with the QTM here and see it. So now the question is, what is the solution? At the beginning, I talked a little bit about controllers, and that is where we'll talk about now. So now we come back to like another scenario where we have an arbitrary assumed token demand denominated in dollars. So it's just an amount of dollars that is essentially available in the market to be spent for the token. So it's the token demand. And we have now an equation. This is like the controller I implemented here for this example. It also includes like a derivative term and so on. Because we don't have the time, I don't want to go into details. If anyone wants to know more, please ask later on. But the important part is that the vesting rate, the supply change over time here, is essentially also bound, has a lower and upper bound. So we don't want this controller to end up not releasing any tokens anymore. And we'd also not want to run into a state where it just releases essentially all the supply at once in a very volatile market. So that is why we need to define some boundaries for the controller as well. And here we see essentially the outcome. We see how essentially the controller increases or decreases the amount of supply vested, and thereby the price essentially approaches an arbitrary implied price level here. So the controller works as it should. And this is again, right, the same as we saw before. So it's again like the token demand here on the left-hand side on the top and the token price at the bottom here on the right-hand side. And we see now 2 additional signals. So here on the right top, we see the vesting rate. And this is essentially what the controller changes, right? At the beginning, when the price drops, then the vesting rate also drops because the demand is quite low. And that's why the controller also reduces the release of new supply into the market. And therefore, the price increases. And then it shoots a little bit over. And this is a problem, or I would say this is like a result of not optimized controller coefficients. I did this on purpose here because it's a little bit nicer to see how it works. But if you would use this in production, obviously you need to optimize the coefficients in the controller to provide essentially best reaction behaviors of the controller for different scenarios. Okay, so this is one example. So here on the left-hand side, we see the same graphs as before. And now on the right-hand side, we see again the same, but with an increasing implied price. So because you can not just define the price being constant over time, but you could also give it an arbitrary function. So here in this example, it could, for example, increase like with a linear slope if you want. And the controller will make sure that the price gets as close to it as possible. At the end, you see it diverges a little bit from the implied price, but yeah, this is just because the controller hits the lower bound and the demand is not high enough to sustain the implied price here at the end. So you can essentially model arbitrary price levels with this. And now we come to the next little question here. So this is again like the linear demand scenario like we had before. And now we consider like a different demand scenario for the token, which is an exponential growth scenario instead of a linear growth scenario, but they have like the same start and ending point. And now the question is, how will the vesting rate change for the given exponential growth scenario? So what do you think when you just describing it from a qualitative perspective? What will change to the vesting rate when you have suddenly an exponential growth scenario? Is anyone bold enough to give an opinion about that? Yeah. Yes. Yeah, you're right. Second question. So the answer is essentially at the beginning, there is like low demand for the token. That's why the release so the vesting rate will also be quite low, and then it will like catch up eventually. We can see the outcome in a moment, but before we go to the result, let's also ask the next question. In which demand scenario will full supply dilution be reached sooner? So we assume that the supply will release into the ecosystem, and at some point, all tokens will get vested. And the question now is, so both scenarios reach the fully dilution of the supply. The question is just, which will be first? What do you think? Will the linear or the exponential growth scenario? Which will reach? Depending on the time period. I mean, that is the question, right? So which is essentially, yeah, you're right. When you look like further in the future, eventually the exponential growth will like outpace the linear growth. But in this example, both scenarios like reach the total supply release within the given time frame. Okay, let's see what the results look like. So first of all, for first question, yes, the vesting rate will be quite low at the beginning because obviously the demand is lower than in the linear case. But then eventually the vesting rate will scale up. And for the second question, it's essentially like the linear growth scenario will get their tokens vested first, because eventually, essentially, it has like a higher demand over the considered time overall, even though it is an exponential growth here, right? And you see like at the end of the time, essentially when the full supply is vested, then the price eventually depegs from the implied price, and it's essentially hitting exactly the point in time where the full supply is diluted. Okay. And we have also the logarithmic adoption scenario. I don't want to go into details here, but it's essentially like the opposite of the exponential growth scenario. Okay, I see the time goes on. I have some more examples also from a Red Cat simulation I did with a little bit different controller implementation, but I don't want to go into the details now. Just hitting on one more aspect of this. So considering we have like the overall supply release into the ecosystem. So this is again our scenario from the start. The question is now, yeah, this is nice and all, but what about the different stakeholder groups? So we have, in general, we have a team behind the startup in general. We have like early investors and contributors, and we also need some supply to incentivize the ecosystem. And the question is, who should get how much with such a dynamic approach of vesting? And one approach, how you could manage this, is by defining vesting weights, where you could, for example, say, okay, at the beginning of the ecosystem, the incentivization should be very high. So we want to have a lot of tokens to incentivize the ecosystem early on, but the team and the investors maybe get not so much. And at the end, the investors will get a higher weight so that we make sure that all the initial investors and contributors get their tokens. It's just an example. And the incentivization should be lower for the ecosystem, like from the initial vesting buckets, because we want to reach a state for the ecosystem that is sustainable and that can essentially incentivize itself through a flywheel effect that is like sustainable and not dependent on more and more supply flooding in from the initial vesting buckets. Yes, and then again, you see them like for the different stakeholder groups, like for the incentivization bucket or the team bucket or the investor bucket, you see like the essential, the outcome of the different vesting rates here. So at the beginning, the incentivization bucket, they will get the most tokens and the other parties will essentially get the least. And then it will like change over time, where at the end, the investors will get the highest vesting rate. And this ends up then in this type of vesting schedule here for the linear demand. And once one of the stakeholder groups got all their tokens, then there are obviously more tokens that can be allocated to the leftover stakeholder groups. So this is one way of how you can handle it for also different stakeholder groups, this approach. So what are now the key implications? So algorithmic vesting based on real in-market demand for the token. So instead of arbitrary guessed vesting schedules, I mean, this is like the main benefit of this approach. We have like, we give the decisions about the supply issuance in the ecosystem, we give this decision to a controller and we don't do it like manually, which is just based on guessing work. And investors get more tokens vested when the demand for the token is high and less if the demand for the token is low. So essentially, it's a little bit like a leverage on the token, right? But it is good for the ecosystem because it stabilizes the token valuation and thereby also the whole ecosystem. And still, individual stakeholders can get and can receive like a constant vesting rate if they want. But this would obviously go at cost of the leftover stakeholders. So there is also the opportunity to mix like the traditional way of vesting with a controller if someone wants it. And yeah, so again, the fundraising conditions or boundary conditions can still be defined because we can, by defining a minimum vesting rate and the maximum vesting rate, we can essentially say, okay, there is a minimum time period and a maximum time period in which you will get all your tokens. So, and therefore it's like a little bit different from the traditional schedules, but I think in the end, potential investors can see also a benefit because when they get their tokens, their token valuation would potentially be more stable and sustainable. And okay, here are some more thoughts before we go into the Q&A. but potential future working areas are, for example, finding the most appropriate controller designs for different token ecosystem KPIs. So at the beginning, we saw like these metrics and KPIs, and we saw the different controller variables. And now the question is first how to combine them, but also essentially how to design the right controller. What is like the best equation implementation? And then the next step is also how to optimize these controller coefficients. Obviously, this problem is not new. It is very well known in traditional engineering tasks. And I think we can draw a lot from there. But still, there is like some work to do in that regard for token economies. And yeah, essentially also drafting what we already started doing here in the chat, drafting the landscape of other useful controller applications for token economies. So just more than just the vesting rate to price impact, because we can also like pair, for example, reward rate to user acquisition or other pairings as we like. And one more note is that at the moment we are working on the QTM, so this quantitative token model, as a Red Cat implementation, because previously it was just a spreadsheet implementation, but now we want to build it, or currently are building it in Red Cat. And in this Red Cat implementation, we also plan to implement at some point potentially these more advanced token ecosystem controllers. So if you want to have a look at the repository, feel free to do so, and yeah, reach out to me if you are interested to work on one or more of these topics. And so I tried my best to run through it so that we have also some time left to discuss some questions and have a little bit of an open floor discussion.
Thank you very much, Achim. Very exciting presentation and very to the point, in the sense of, like a good introduction, a good motivation, and then results with respect to the question that we are pursuing. Thank you for that. We were collecting some questions in the chat in the meantime, trying to not interrupt you, to not lead you on a path answering topics that might be tangents to what you were trying to say, but now would be a time to recollect those questions and approach those details in more granularly. So let me maybe start with something that I'm kind of interested in as a precondition for the whole model that you're building here. So what are the assumptions about the ecosystem that you are that you're making in order to allow for this model to work? So do you assume that this is kind of like an economy where there is some revenue or some output generated, and that this revenue is linked to, or this revenue distribution is linked to the ownership of the token? So is it kind of like this one token system with, like a production economy where you would say, okay, if you own this token, then you also, like will receive some part of the adoption generated revenues? How would this, like, is this the case? And how would this look if you are, treating a more sophisticated ecosystem where those rights associated with those tokens are more granularly divided?
Yeah, good question. I would say this approach is not like limited to one or the other detailed token design, because it's just about the question of how supply gets emitted into the ecosystem overall, and it not really just it does not account like for certain individual or detailed like utilities for the token or how it is used exactly. It is just like a matter of there is a certain demand for the token wherever it comes from, and on the one side, and then there is a certain amount of supply that gets released into the ecosystem, and this together essentially creates like the price level or the valuation of the price of the token. And yeah, and we want to create like more sustainable ecosystems, right, where we don't have like what we saw in the past. Obviously, yes, we were like in bad market conditions, and there is like that we have been in a bear market, but there are some curves of token valuations where you see, no, it's not just like the bear market. It's really also due to the release schedules of the token. So it's always like a mixture, but I think we have a lever and we have also a part in this. So it's not just like defining the fundraising details and just having like, here is the vesting schedule and everything else will be done by the market and it's not our responsibility. I think there is also responsibility for us, and that we look into this a little bit deeper and apply like these concepts that I presented here today.
I appreciate this. Thank you for this clear answer. With respect to the supply that you're mentioning, like you say, okay, there is a demand on the market for a token versus there is a supply that is to be distributed. Is there any limitation on the supply? So, like, are you presupposing that there is a fixed number of tokens pre-minted that is vested and being distributed? Or are you just saying, we don't know about the fixed number of tokens, we will mint on the go depending on what's going on? Or what's actually happening here? So is this a fixed supply limitation that you have, or are there more sophisticated monetary policies also possible?
Yeah. So again, everything is possible, right? So here in this example, it's fixed supply, but obviously we can tie into the minting rate as like one control variable as well, and the burning rate, and then also mix it into the whole equation. And I know some are already doing it. So that is not really new to use like controllers in general for token ecosystems. But I think we need to head more into this direction and give this like more emphasis for designing token ecosystems in the future. So in a nutshell, it doesn't matter if it's like inflating token supply or not. It's just like then applying a different set maybe of controllers.
Okay, thank you. Yeah, this makes sense. This is very clear. Cool. The next question, maybe let's look into the chat. We have a lot of going on there. So yeah. Okay, so this is answered. These are the examples that you asked for. Then we have a question from Marcus. He says, the question is basically an optimizer or uses one. Is this correct? So is this how you can think about the controller in this context?
I mean, optimization of, yeah, I mean, in a sense, you can think about that, right? But yeah, a controller is essentially like using an input signal and processes it, and then, or more input signals, processes it, and then giving it to an actuator or to the ecosystem, and then try to essentially reach a certain target value or target values. And in that sense, yeah, maybe I would say the term optimization is often used in a different frame, but yeah, in a sense, it's similar.
Yeah, and this is interesting because on the slides that you've shown, the target value that you were actually targeting was the token price, right? So this is what you wanted to
in this example here, yeah.
Exactly. And I've seen from the diagram that you are targeting a constant token price, or at least this is what you were showing in the graph. But I assume that this is not no limitation, right? So you could use more sophisticated price trajectories, like assume like a 1% growth in price, like, or assume a return rate for the token over a year, whatever. Which is actually on the right hand, and in the right panel you have an increasing price. Yeah.
Yeah, exactly. So that's what I mean. You can essentially apply arbitrary functions to prescribe the price. And then
nice.
The controller will essentially work for it to make it happen.
Perfect. What I was interested in on this slide especially is, why does this price derail from the target at the end of the interval again? So is this something that is specific to the simulation, or is this kind of coming from the increased adoption of the ecosystem, therefore, and more increased market demand?
Yeah, good question. So here in this specific case, so this is not general, but in this specific case, you see like the vesting rate, the supply release per day is the vesting rate. It approaches essentially its lower cap, so it can't drop lower. This is not zero, by the way, because it's a logarithmic scale, and so it's a non-zero value that is approached here. And this means that the price is still, the prescribed price is still increasing. So essentially, the controller is essentially out of range. So it can't go lower to account for this ever increasing price, and the demand that we prescribed is then not enough to keep up like the peg with the implied price.
Nice. And the same on the left side, in the left panel, you have the opposite effect.
You mean this one here?
Yeah.
This is a different effect. Here we reach like the fully dilution of the supply. And that's why the issuance of new tokens into the ecosystem stops. And at that moment, essentially, there is nothing that the controller can use to counter the demand, essentially. And this essentially leads to depeg from the implied price.
Ah, nice. And you see the same slope as in the top left panels, like, because this is the increased demand, right? That you have the demand, and this demand influences the increase in token price on the right bottom, right?
Yeah, that's right.
Nice, cool. Okay, yeah, perfect. What do we have here? The next question is essentially what you want to solve the distribution schedule to early investors and the team based on system performance, or based on one KPI that is encoding the system performance. This is the goal of your model here, right?
Sorry, can you repeat that question?
What you want to solve is a distribution schedule to early investors. So like by vesting means like withholding or increasing the release, right? Like either doing this, like adjusting the release amount based on system performance. And you want to do this kind of only, like you made the separation between investors, team, and then incentivization, right? Like, so what is this incentivization group? Are those the users of the ecosystem or the adopters, or like what's going on? Who gets what?
Yeah, so this was just a distinction like in 3 meta buckets if you want. Obviously, those meta buckets can be defined more on a more granular level. So incentivization, for example, could be like airdrops for certain actions in the ecosystem, or it can be incentivization of liquidity. So when the protocol wants to rent liquidity from the market, or it can be like rewards for certain actions in the ecosystem, or even for staking, like bootstrapping the staking bucket, for example. And yeah.
Okay, so if I understood this correctly, what you're doing still, I mean, as you see in many token projects, you are assuming a token distribution pie. You say like 20% go to this group, 50% go to this group, and 30% go to this group. And then you would have like for each token in the supply, or each new token minted, dependent on the model that you're choosing for fixed or variable supply, you would then know how much of this amount is supposed to go to each of the groups, right? And for each of those groups, you then can define an individual vesting schedule, right? This is also what you said.
Yes. So just to make it clear, the overall allocation to the individual stakeholder groups must not necessarily like overlap with these vesting weights. So we can still like apply different vesting weights. So like assume that we have like one stakeholder that has a lot of supply being allocated to, must not necessarily mean that this one is also like the prioritized one when it comes to receiving the vested tokens. So it can be, but must not necessarily be.
Okay. Okay, nice. What about the explanatory power of your model with respect to different variables? So you said like in the beginning you have different groups of dependent and independent variables, or controlled and controller variables that you can utilize. And then you make the selection. You say, okay, let's choose this one to predict or to control this one, right? But we know that the token ecosystems are much more complex, and have interdependencies between those variables. So first question would be, in your control approach, does it only work if you assume that all other variables are fixed? So you don't make any changes to like you have, like you are controlling based on the change of one variable, but you keep all the other fixed? Or is it possible to kind of say, no, actually everything can change, and I'm going to make this control based only on this connection between the two variables that I assume?
Yeah, this is exactly where it should go towards to, right? So this is like just a minimum case study, just focusing on the vesting aspect. But obviously, as you said, in the future or in general, we can think of like many different pairs of control variables with actual ecosystem metrics and KPIs. And they are obviously then have also interdependencies. So it's a really very chaotic and nonlinear system. And we have to really think a lot about this, how to make sure that those controllers are not like maybe working against each other, or if they do, then we need to define like what is like the prioritized metric, for example, or the higher weighted control variable, for example. So it's like a new topic, like it's essentially a topic on its own to think about. This is also what I listed in the future work slide, where I said, okay, now we have to think and to extend this idea essentially for the whole ecosystem to a whole ecosystem, and essentially go approaching a state where we have less and less human interaction and yes, less and less human decision making, because every time a human makes a decision for an ecosystem, it's a potential attack vector.
Nice. Okay, so you're saying multiple things, right? So like as you mentioned and emphasized during your presentation, walking away from like governance structure would be like ideal, and on the other hand, you also mentioned that there are two ways to approaching this, right? So either you build multiple controllers linking two different variables, like one from each side, and saying, I want to have this system dynamic implication, and then investigate the interdependencies between those controllers and kind of make some override or like weighting decisions on what is more important. Or the other alternative would be, I assume, making one controller that has all of those control variables as input variables to be able to integrate kind of like everything that's going on into the decision making, right?
Yeah, exactly. And I think in the end, we maybe might end up in also leveraging some machine learning approaches because it's like so complex to find like and optimize for the right coefficients, because each of these controllers comes with a set of coefficients that essentially tune the controller. And that's like the next question, how to pick like the right values for them, right? How to tune them right. And I think at some point when you have like such a complex system with so many control variables and metrics, then maybe you want to use something like neural networks or machine learning approaches to make it a little bit more efficient in the design and optimization process.
Nice. The next question is, if we could plug the controller with rewards emission function, it could play out great for the economic sustainability in the long term. What are your thoughts on this?
Yeah, that's right. It can be, but again, it also then depends on how you tune the controller, right? So that is like coming then to the next level of detail. In general, it's a good idea to use like a controller to steer the reward issuance rate. But then the question is, okay, but how exactly should this look like? And what metrics are used? So are we also using like the price, for example, because the more rewards we pay out into the ecosystem, this can like cause on the one side a price drop because we release more supply into the ecosystem. But we see very often in the market that at the beginning, when you, for example, announce like for a project, we have like high rewards paying out, then this will also attract some demand for the token because people want to buy it, to stake it, to receive the rewards. But essentially, this is not sustainable if it's applied that way. And therefore, obviously, yes, applying a controller setup would be very nice, very good idea.
Perfect. The next question is, thanks for the great presentation. Could you dive into the controller equation a little bit? As far as I saw, the supply release is partially based on the past price of the tokens. What or how many time lags did you use and why?
Yes, good question. I think this refers to this equation here. Here is essentially referring to 2 time steps back. Obviously, if we would use this in production, we might want to introduce a little bit more smoothed out signal. So this is obviously like an artificial example where we have not so much no volatility on it, but the reality is like there will be potential speculation bubbles and high volatility in the ecosystem, and we don't want to have this controller making like very sharp decisions and leading to potential unstable situations. But again, looking into this in a more deep level requires like also optimization, because it's the end, like what is like the best time weighted average amount we should use. So no one can answer this unless you do like some iterations, and the answer will probably be the best time weighted average or the best coefficients for the controller for this situation will look like this. But as soon as the situation diverges, like from the initial assumptions, then you maybe need some different parameters and coefficients, and you very quickly you end up like in a very complex optimization problem, and then again you end up by probably you will need to use some machine learning approaches. And yeah, obviously you don't want to optimize the controller like for one situation, but essentially like for a space of different scenarios that can happen. And it should preferably like handle all these different scenarios with sufficient efficiency.
Cool. So let me just interject very quickly here with a question of, the practicability of this, in a sense. Did you test this already? Like, is this only theoretical work with synthetic data, or do you have feedback from system integration and observations of real economies as well?
Yeah, good question. Yeah, so this is really just like more on the ideation level, paired with some like simulations, as you saw. That's why it's still like more at the beginning, but I think it's like the concept, and I think the concept has some potential for like more application and more advanced token economies in the future, and that's why I thought I bring it out, and maybe someone else wants to build on top of it, and we are already also discussing internally on how and when and if we can like apply it also to our portfolio companies and early startups.
Excellent. Yeah, nice. And the next question in the chat is, could you use, I assume that is the question, could you use metrics for decentralization instead of price, right? Like the target value would be not price, but something else that you target.
Yeah, obviously, yes, you can. So it would be like another like ecosystem metric, decentralization, or number of nodes or whatever, or unique nodes. And yeah, you can do it, obviously. So there is no limitation, right? So the list, these two lists are not complete here.
Yeah, cool. And the next question is, if we imagine a situation where at some point of time there is a sudden spike in price for reasons that are not connected to the adoption of the product, and so is potentially unsustainable and thus can cause dangerous destabilization of the system, how would you think about a mechanism that can introduce automatic cool-off? What factors apart from price volatility would you use in such a mechanism?
Cool-offs for what? For the vesting rate, or for the vesting, or?
Yeah, so I assume the question is like, how stable is the system, or how stable is the controller with respect to sudden, unexpected, and unconnected kind of or unconditioned changes in one of the variables with respect to the other, and if the controller would kind of overreact based on some change that is independent of the token demand, but something else. You could maybe have a cool off for the controller so that you don't react immediately, or that you just postpone some sharp changes in the vesting rate, so that you don't have very strong sensitivity to the input variable.
Yeah, so the question is spike in what? Spike in price, I assume. And the beauty of this controller is it is actually demand agnostic. So it doesn't require this token demand as like an input. It really just uses the price itself. So as soon as there is a spike in price, then yeah, obviously it will then change like the vesting rate. But as stated at the beginning, we need to introduce like caps, lower and upper boundaries for this vesting rate, especially like for these very volatile situations in the market. So for example, when price suddenly spikes up, then we don't want that suddenly the controller causes like a big vesting chunk, but it should like be limited to a certain amount. So this
exactly
already like stabilized the situation, but obviously maybe in a certain design, you also maybe want to apply some additional delays or something. So yeah.
Yeah, so if you have, for example, a speculator spike, right? Like, so people are just, like increased speculation, and like there is some hype about an ecosystem without really, like a real token demand for the adoption of the system or the economy, right? So this would be then kind of the question: are you still you say yes because it only depended on the demand, right? Are you still, giving away more tokens to the team and to the investors based on an increased vesting schedule because you have, like more price and more demand that is signaling a higher adoption, or do you decouple this somehow and try to say, yeah, based on this, you are not really, qualified to receive more tokens sooner because it's just a hype thing, right? Yeah, and then the question is, what factors apart from price volatility would you use in such a mechanism? So you already said that if there like some boundaries there are, right? Like, so you would make some limits and say, okay, you don't want to have something exceeding a threshold, for example. You're muted, I think.
Yeah, and also applying potential like time-weighted average signals on certain time scales. But again, this is also like a parameter in itself that has to be optimized for. So
cool.
Even if you use like a controller, it's not as simple as, okay, you use a controller and it solves all problems, because you can only have a controller being optimized for a specific situation of the ecosystem. And you can end up in other situations where the parameters or the coefficients of the controller are not optimal. And I mean, that is then where the engineering starts, right? Where you weight like these different situations and optimize for a broad variety of different scenarios.
Nice. Then we have one question that is kind of related to a point in time where you presented like at 4 p.m. 33 minutes. Wouldn't this result in higher user churn rate later? Which I assume was when you explained the exponential vesting schedule, the exponential demand curve that would result in a higher vesting schedule later. So then the question is, I think, appealing to this effect. So wouldn't this result in higher user churn rate later?
I don't think that you can like say this. It's not like connected in that way, I would say. So if the demand like increases further and further in the exponential growth scenario, I mean, at one point we will have vested all the tokens, and then the controller is essentially out of control, and then the price is essentially under free market forces, and that means that then maybe another controller has to take over, like for example minting and burning to control the price action. It will be like one idea. Yeah. So
okay, but there's a follow-up comment from the same person. Maybe this explains more the context. Based on the lowered incentivization vesting weight, so like this apparently has something, is the question is related to the weight that you've described, or is it based on the assumption that the system can sustain the rewards distribution by that time?
Exactly, that is the rationale behind it. So we assume that at the beginning we need a lot of tokens to bootstrap the whole ecosystem. We want to attract many more users. We want to really like have supply available. This could also be locked up, but in the end we want to have like something that we can work with to attract adoption. And that's why we maybe want to apply a higher weight of incentivization at the beginning. And at the end, we should have created a token ecosystem that does not depend on the initial token allocation buckets anymore, but has like a circular, sustainable behavior where we have like where we can essentially afford all incentivization mechanisms out of like the circulating ecosystem.
Okay, and then there's the follow-up again. But in this way, groups can manipulate the vesting releases by playing with the price, essentially, if it has a low liquidity depth. So connected to the price spike comment. Sorry, this is not to the question that you are answering now.
can manipulate the vesting releases by playing with the price. Yeah, that's correct. And obviously, I mean, that is then again like the controller fights against the market, right? So maybe there will be some players in the market that want to exploit it, but I think once this is known, potentially the market itself could end up arbitraging the price towards the implied price. So basically front running already the controller. But obviously there are potential, I mean, edges that someone can have potentially to make a profit out of diverging prices.
Nice. I have a follow-up question, if you allow. I mean, we are a little bit over time already, but I mean, what you're explaining here is kind of, you know, a perspective on system governance, right? Like you're saying, okay, we have a system parameter, system mechanisms. We are particularly talking about the distribution mechanism of tokens here in this case, and the question is, how do you want to govern it, conditional on some system KPIs or some system metrics. So the application of control theory or PID controllers in this context for, you know, finding dependent and independent variables and trying to establish a connection between them and, you know, define automated governance mechanisms is something very interesting to pursue in general for all of the ecosystems and for all ecosystems mechanisms. So you started here this approach for a pair of variables, you know, like demand or price and demand and price, actually, yes. But it would be interesting to explore this further, right? It would be interesting to go beyond and find controllers in all ecosystems or in all mechanisms that are allowing you to steer the economy in a particular sense, not only related to the vesting schedule, but related to all the other mechanisms that you have in your economy, right?
Yeah, exactly. And that is why I also listed it here in future works, like finding other pairs of control variables and metrics, combining maybe not just one control variable with one metric, but maybe a bunch of control variables with a bunch of metrics, how they are interconnected. And essentially it's not just about choosing these pairs, it is also like, what is the best controller design in itself? Because I said, like in the beginning, you can also apply different equations on how to define such a controller, and they have like different advantages, disadvantages, and then moreover you have also additionally like the optimization of the different controller coefficients. So it's really like there is a lot of it really explodes like from the complexity you can think of, but I think it's worthwhile to go more in this direction, because as you said, we can mitigate like governance processes that are always like risky.
Yeah, this is nice, and I would be very interested personally in joining this research arc. So you can sign me up for joining this group. I mean, we're thinking about similar problems in our work and our daily use cases as well, where we would, you know, for a system component, for an individual element of the economy, try to define those little controllers that are giving us guidance on how particular mechanisms should be governed. So this is clear and this is understandable, like following the same approach as you have outlined here. The main question then is the composability of those controls and control mechanisms when you assemble the system into a bigger whole, right? So everything is nice and good if you like find individual controllers that are just working, you know, like for this one subsystem or for this one process, but this can totally derail if you build up to more sophisticated solutions when there are, you know, multiple effects, even trade-offs between them.
And I think that is essentially where simulations come into the equation, right? Where we can't just like oversee all the consequences of applying different controllers anymore, because it's just too complex to follow up with our human brains. And then this is when we have to apply like simulations that automatically essentially also optimize for these different controllers or their coefficients. Potentially by using like machine learning algorithms or something. So I think we come very quickly to like certain borders where we can't approach it just anymore just with analytical approaches. from my perspective.
Yeah, so you're saying instead of bottom up, construct the controller and then like understanding analytically the effects, more like a top down approach where you see like the data, you have the data input of like those are the trajectories of particular data, and then you try to learn back or like reverse engineer from this data a control relationship between different variables, right?
Yeah, so that's how I would approach it.
Cool. This is very nice. So from my side, this is it. So like it was very interesting, and I mean the chat also applauds and is very excited about the presentation, and everyone was very is very grateful for the way how we spent the last 70 minutes or so. So unless there are any other questions from the group or from the chat, I would like to congratulate you on this amazing session, and thank you so much for presenting this to us. And we are more than happy to continue the conversation in this direction with you.
Yeah, thank you so much for having me, and have a great rest of your day all.
Bye-bye.